Today's video is not about rescuing a great device from the 90s. Today's video is about rehearsing, buying actually devices to sort of rehearse or practice with desoldering and soldering capacitors. Because as you might know, this channel is all about rescuing hi-fi from the late 80s, during the 90s and early 2000s by just looking at working devices that still are just performing okay in the sense of all the selectors etc. Work correctly. Maybe if you are with a CD player, maybe you start to see that it is struggling to read CDs. That might be still okay because the laser might be okay. It's just that the power section is not giving a clean current to the laser. And so replacing the capacitors in the power filtering section might revive that CD player. But I would say the best device to practice and actually the easiest one to rescue are actually amplifiers, because the thing that normally goes wrong in amplifiers is the capacitors dry out. This device is already some 30 or 35 years old and it was using general purpose, very basic quality Nichicon capacitors. So it was sounding terrible. The amplifier had no high frequencies anymore. It sounded mumbling and very, very dense sound. It was just really bad sound. After changing all the capacitors, it is sounding fine. Fine again, I would say fine because it isn't a great amplifier, so it's not a great sounding one. Let's see which amplifier this is. This is a SONY TA-FE 310R, and it's basically almost the same device as the TA-FE 510R. Actually, the main board, I don't know if the light is good enough to see it in the camera, but the main board says TA-FE 510R. It doesn't even specify that this is the 310 version of the board. The only difference that Sony did was in the 510 it puts slightly larger capacitors, so 6,800, while the 310 comes with 4,700. Here we have the one that came out. So it came with a 42 volt. I think I've put 50 volt now, so slightly higher spec, but very, very slight. And I think this is the cheapest stuff that I've seen. It's not a bad brand. I think these are Nichicon. But this is a very basic line of Nichicon. I see a W. That is probably the series of these capacitor. So not surprisingly, they dried out because they were like the lowest quality of the manufacturer. What is the other difference with the 510? The transistor, the power transistor, is slightly cheaper and more basic in the 310. This is a 2 times 35 watt, I think, and the 510 is a 2 times 35 watt. The 510 comes with a specific transistor for audio, while this comes with a general purpose. This is not even an audio specific transistor. And the other difference are these two capacitors just in very near the transistor, which probably gives current to the transistor during operation. And I think there were two others that were also slightly different in the 510 from the 310. I figured that all out from the service manual, where you could see the list of components. Actually, I've put these two capacitors of 220 microfarad, which were actually the specifications from the 510. I should have bought bigger capacitors for the filtering, since they hardly cost any more than the ones that I've put. So I could have put the ones that the 510 came with to have a bit of more breadth in the current filtering. But the really limiting factor is this transistor. It's just not a good transistor that this power amplifier comes with. But it has a couple of things that makes it interesting for practicing, and that is that it has some difficult aspects and some easy aspects, and it's that mix that I thought was making it interesting to comment on this video. All the capacitors are looking towards the camera. It's the first time I work on an amplifier or cassette deck or CD player where all capacitors are looking in the same direction. The only two exceptions are the bigger power filtering capacitors, which are looking towards the back. When I say looking, I mean the negative pole. The negative pole is looking towards the back. All the others have the negative pole looking to the front. You know, the negative pole from the strip. All capacitors in the plastic jackets have an indication of which one is the negative pole. Most capacitors have about the same specifications, so you won't have to buy many capacitors. So that makes it again for a second or third project to start learning to desolder capacitors an easy one, because you will buy very popular capacitors that you will use in many other projects, and there isn't much of a variation in the specifications. Actually, you will see some voltage differences, but you can put them all from look in the main board for the highest voltage for that specification, that capacitance, and then put the highest voltage in all the locations. No need to put lower voltage capacitors in the other ones, because nowadays capacitors have become so small that you will find that all the replacements, even if you put higher voltage, will still fit. The diameter won't be a problem. You will see here that this row is a bit more busy, so you will have to maybe make sure that you don't put a too big capacitor in these locations or the ones next to it, but otherwise you shouldn't have too much problem with this low specification. So we are talking about 47, 4.7, 10 and 100 microfarad, and all of these capacitors normally come in a 5mm jacket, so you shouldn't have much problem. Sorry, I said 5mm, maybe it's actually even less, 4 or 3.5mm. And the other thing that makes this amplifier, the 310 or the 510 for that matter, great to work with is the main board is not very big. The heatsink is very tight and snug, screwed on this sub-chassis, and this sub-chassis is very easy to loosen from through 3 screws in the underplate. So once you have that sub-chassis released, you take all the screws here from the back that are holding the input jackets and the speaker terminals on the frame, and then one screw, actually only one screw, that one over there. Once you do that, the main board is as easy as moving a little bit to the front face and then pulling it up. And because that heatsink is so strong on that sub-chassis, you will be able to turn upside down the main board many times. You can rest it on the heatsink, not as in other amplifiers where the heatsink is almost only attached to the board via the transistors. So while you're manipulating the transistor legs, the soldering will be under stress because of the bending of the heatsink from the main board, but not in this case, so that makes it super easy to work with. But it is a very difficult amplifier because the main board has very thin copper lanes, so they will easily get damaged while you are desoldering. And that's why I said it is a good amplifier to learn to desolder with more care. The other reason is because this was manufactured in mass, that the capacitor legs were probably with a machine bent, and they are bent 90 degrees against the main board. So when you're working on the underside, you will see that even with the suction device, when you take all the soldering, you will still not be able to grab the leg and put it up straight up so that you can take the capacitor out. And if you try to do that, you will probably damage the copper lanes. So what you will have to do probably in this amplifier is, while you're working on the other side, take the soldering iron, liquefy the tin, and while you're doing that, from the other side, with your fingers, pull from the capacitor very strong, in an angle, sort of to loosen one leg. So if you have 2 legs, touch the soldering iron with the soldering iron, you get one out, then you go to the other leg and you pull it completely out. You will still have that the holes are covered by tin, That's one with the suction device. You go again through the holes and you clean them up so that you can put the new capacitors later on.